In the previous two videos, we were really focusing on looking at a formula and writing a name from that formula. On this video, we're going to do the exact opposite. We're going to go ahead and write a formula from a name. So it's similar, but there are a few little tips and tricks that I can show you. One thing you're going to find very useful is if you know the representative groups of elements and their charges that are associated with these groups. I'm going to go ahead and show you a periodic table on the next slide, and it will demonstrate which groups contain which representative charge. You probably already have this document and the representative charge is written above it, but if you don't, you probably should do so. You'll notice that above hydrogen there's a 1 plus. Above beryllium there's a 2 plus. We skip over that entire middle section to where you get to boron, that's 3 plus. Above carbon is 4 plus or minus. Above nitrogen is 3 minus. Oxygen is 2 minus. Fluorine 1 minus. And above helium 0. The method I use for writing formulas for ionic compounds, I call it the crisscross method. I'll basically separate the cation and the anion. I'll put its representative charge by each one of them, and then I simply cross them, making the charges the subscript on the other thing. So for example, sodium chloride. So sodium symbol is Na, chloride is Cl. So I look at my periodic table. Sodium is in the first column, and they have representative charges of 1 plus. Just so you know, sometimes you'll see it just written as plus, but it's not incorrect either way. You can write it as 1 plus. The 1 is understood if you don't put it. Chloride, okay, it comes from chlorine. I look at chlorine, it's in group 17. Those all have a 1 minus charge. So when writing the formula for sodium chloride, I simply put the cation first, then the anion. This 1 comes down here. This 1 goes over here. And so because they're both 1, it's understood. And so sodium chloride is NaCl. All right, this compound, potassium oxide, okay, potassium is K. I look at the periodic table, it's in the first group, so its charge is 1 plus. I look at oxygen, it's in group number 16. They have a charge of 2 minus. I write the cation first, followed by the anion. This 1 comes down here. This 2 goes over here. It's K2O. That is the formula for potassium oxide. Notice only the 2 moves. All right? I don't move the negative portion. I only take the numeral 2 and put it down here as a subscript. The reason why the negative doesn't move, okay, when it's written as a superscript, that's indicating a charge, but when it's written as a subscript down here below the line of script, it's counting. It's telling me how many atoms of each. So I have 2 potassiums, 1 oxygen. It wouldn't make sense to put negative 2 down here because if you're counting, what's negative 2 potassium? You know, is that a hole in space where potassium should exist but it doesn't? Things fall in there like socks and things? Well, no, that doesn't make sense. So subscripts will always be positive. So 2 potassiums, 1 oxygen. And really what this means is if you look, and this will kind of make sense. Potassium has a 1 plus charge. Oxygen has 2 negative charges. So it takes 2 potassiums to negate oxygen's negative 2 charge to make it a neutral compound. This example, we have lithium sulfide. So I look at the table, there's lithium. Once again, it's in the first column, it has a 1 plus charge. Sulfide is in group 16, it has a 2 minus. So lithium sulfide, LiS, the 1 goes over there, the 2 comes down here, Li2S, lithium sulfide. These appear fairly easy so far. Well, here comes your first wrench. Calcium oxide. Let's look at calcium oxide. Calcium is in the second group, so it's Ca and its charge is 2 plus. Oxygen, once again, group 16, it's 2 minus. So I put the cation first, the anion second. This 2 comes down here. This 2 goes over here. All right. What do you notice? The charges are equal and opposite. Likewise, the subscripts are equal. So just like in math class, whenever you have numbers that are, the same or divisible by one another, you want to reduce, right? So in this instance, because they are both 2's, well, they both go into 2 one time, so the correct formula for calcium oxide is CaO. Whenever you have equal and opposite charges, you want to cancel them out. Calcium oxide's formula is CaO. Here's another example. Okay, we have sodium nitrate, so I'm going to write sodium, Na. It's in the first column, so it's 1 plus. Nitrate, notice nitrate ends with ATE. This is not nitride, it's not nitrogen. So you must notice, all right, hey, this thing is a polyatomic. It ends with 8. So what is nitrate? Nitrate is NO3, and its charge is 1 minus. So when I write the formula, just as before, the cation goes first, anion goes second, this one comes down here, this one goes over there, NaNO3, sodium nitrate. Here's another one involving a different polyatomic, ammonium. Ammonium is one of the only polyatomic cations you have to know. Ammonium is NH4 and it has a 1 plus charge. Bromide is bromine, it's in group 17, and it has a 1 minus charge. So, once again, cation first, anion, this understood 1 goes down here, this 1 goes over here. It is NH4Br. I think this is as good a time as any just to mention to you guys, notice the 4 doesn't move. The 4 doesn't come down here by the bromine. The 4 is part of ammonium. NH4, this tells me that there are 4 hydrogens. Okay, this 4 doesn't move. The charge moves. The charge is an understood 1. The charge came down here. Notice there's 1 bromine, and there's only 1 ammonium. That 4 is part of ammonium. If it's not NH4, it's something else. If it's like NH3, it's ammonia, a household cleaner. So that NH4, that 4 needs to stay with the hydrogens and that nitrogen. In this problem, we have magnesium phosphate. So magnesium is Mg. It's in the second group, so it has a charge of 2 plus. Phosphate, polyatomic ion, PO4, 3 minus. So I put the Mg here. Phosphate, the anion goes here. Notice the 4 stays with the phosphate. This 2 comes down here, and the 3 travels over this way. Now notice I can't just put a 2 here because then it looks like 42. All right? So how do I designate that there are 2 phosphates? I need 2 of this entire group, and it's not just 1 phosphorus and 42 oxygens. Well, the answer is you use parentheses. So to correctly write magnesium phosphate, you go magnesium, the 3 comes down, and then the phosphate is PO4. You got to put the entire thing in parentheses, the entire anion, and the 2 comes outside. So if you were doing an atom inventory, just to kind of mention what's going on here, if I was going to count the number and type of elements present in this compound, all right, there would be a total of 3 magnesiums. The 3 applies just to the magnesium. And just like in algebra, whenever you have the parentheses and then a number outside, that's multiplication. So inside there's only 1 phosphorus. So there's 2 of them. There's a total of 2 phosphorus. And there are 4 oxygens inside, but there's 2 of them, so 2 times 4 is 8. So 3 magnesium, 2 phosphorus, 8 oxygen. All right, I've got a couple of problems I want you guys to try to practice here on your own. Barium iodide would be the first one. So go ahead and pause the video, take a moment, and try to answer or write the formula for this compound. Okay, when writing this formula, barium, you look at barium. Barium is in the second column. So barium has a 2 plus charge. Iodide, okay, so iodide is iodine, but it's an ion. It's in group 17, so it's 1 minus. So when I write the formula, Ba, the I goes here. This 2 comes down this way. The 1 goes over there. So barium iodide is BaI2. All right, try this one, magnesium sulfide. Go ahead and pause the video here for a moment. Try to answer it and see if you get what I come up with. Okay, magnesium. Once again, it's in the second group. Mg is 2 plus. I look at sulfide. It's in group 17. 16. S, and it's 2 minus. Magnesium, and then sulfur. This 2 comes down here. This 2 goes over there. Notice they are equal and opposite, so you must reduce the formula for magnesium sulfide, MgS. And here's the last practice problem of this type, magnesium sulfate. Okay, first thing I want to mention to you, notice sulfate, ATE, polyatomic ion. So go ahead and pause your video, see if you can name this or write the formula for this compound, and see if you match up. Okay, welcome back. Magnesium, once again, still in group 2 as a 2 plus charge. Sulfate, polyatomic ion, SO4 2 minus. Mg, SO4. This 2 comes down here. This 2 comes over here. But notice equal and opposite. Magnesium sulfate is Mg, SO4. The 2's cancel.